In this exercise, we're going to be working with panic and recover. Specifically, I want to show you how to build some middleware for an HTTP server that will basically just recover from any panics that happen to arise in your code and will allow you to render some sort of useful page for your end user. So to get an idea of why this could be helpful, I think it's best to start with this main.go, this really simple server I have set up here. I'm going to go ahead and start that up. And I'm going to go visit localhost 3000, and you'll see the default page is just hello, but if I go to /panic, this page gives me an empty response here, error empty response, and it looks like something went wrong. Well, if I bring up my server, you'll see here that we have a stack trace here. It looks like a panic. Up here it says panic serving, so blah, blah, blah. We have a panic, but on our website, we don't really render anything. So this is what I really want to show you how to recover from is on this part of the page, I want you to see how to capture panics in your web applications and to then use them to, render a useful error page for your users. So if you have something like, I don't know if this one, this is a 404. But anyway, this is a bad example, but if you find like a status, a 500 page or an internal server error type page for a website, usually these are pages that are rendered when something like a panic happened in the application or some sort of error that was unrecoverable occurred. And they want to just tell you that something went wrong, but that's about all the information they can give you. So these types of pages are just super useful for that. It's also nice to recover it in case you wanted to debug it. So if you're in local development, that'll be the next exercise. Actually, we're going to look at how to make what we build here even more useful for your local development. And I think that should about cover it. Before we jump into the exercise, I do want to say that you should read over the README. It covers all the things you should be doing. It'll give you an idea of sort of what steps to take, what sort of things to build. As I said, it's basically just a panic recovery middleware, so if you want to go try to take a stab at that, that's fine. There's also a link here that discusses what panic and recover are, as well as the defer statement, which is necessary to use or necessary to use recover rather. So I definitely suggest checking out this article as well and reading it, and getting a feel for how they work so that you can go ahead and try building this. We're going to start this exercise by diving into the code. I just want you to see what's going on here, and then we can move on from there. And I'm going to stop at one point to talk about when to use panics. I will say that the way I'm using panic in here is not ideal, but it's sort of just meant to be a simple example, so that's why it's there. So looking at this code, we've got three different handler functions essentially, and each one of these is at a different path. So we've got panic, panic after, and just the root path. So panic will just be a function that panics. Nothing else happens, so you don't have to worry about things being written to the response writer. Panic after is going to panic after we've already written some data to the response writer, and we're going to use that a little bit later in this exercise to look at how, if something's been written to that, is there any way we can sort of handle that situation? Is there anything we can do to sort of make that a little bit nicer so that we don't have this partial success message along with an error message later on? And then finally, the hello handler is just this function down here. It just prints out a hello message, so it's nothing that we need to worry about. It's just sort of there so you can see how a regular page works and verify that your code is working correctly on those pages as well. So I linked to this article here in the useful links section. I'm definitely just going to say read it if you haven't. But the big pieces of information to pull from this are, in order to recover from a panic, you need a defer statement. You need to be recovering inside of a deferred function specifically. So what happens when we defer? I'm just going to go ahead and just put this in here just to show you. So when we call defer, we have a function call like this, and in here we have some code. And this is a closure, or it's an anonymous function, but you could do this with a regular function. So it could be func recover, recover stuff, something like this. And then in here we could have something like, something like this, and then we could change this code here to just be something like recover stuff. So these are both the same thing. All I'm doing in this other case is I'm just creating this anonymous function here, so I'm just creating it inline. And the reason you do that is generally so you have access to any of the variables inside of this whole panic demo inside of your deferred function. So whenever you call defer, it takes this function and puts that on a call list, or a list of functions that need to be executed, and it will get executed after all of our code in this function is run, or if, say, this code happens to panic somewhere, it'll get run after that sort of thing happens, but it'll get called before this panic demo function completely returns. So there's a lot of useful ways there's a lot of ways to make use of this, but the one we're going to be looking at is recovering. So what I mean by that is we've all seen panic with some message, something like this, and this will cause our program to panic and to stop going through its normal execution flow. Well, you can also do error : recover. And this will be the opposite of panic. So while a panic will cause your program to start panicking and to leave the go routines and things like that it's in, the recover will actually take the error that was passed, or the message that was passed into a panic, and it will return it here to this error value. So I do want to mention before we move on that this recover function, it's a built-in function just like panic is, but it will not do anything useful if it's not inside of a deferred function. So if we were to put it right here, recover, it's not going to be useful because this code's not going to be executed. What happens is whenever this code panics, our program stops running at that point and starts to panic, so this code never gets a chance to execute. But things that are inside of a deferred function call, they still can execute because, even though we had a panic here, it might make sense to need to close up some stuff or to recover from that panic. So it's important to remember that if you're ever using recover, it needs to be inside of a deferred function. Okay, so now that we've seen how to recover from a panic, I'm going to actually just show you this here. We're going to do format.fprint, w, error.error. Let's see. Oh, sorry. I messed up there for a second. This isn't going to be an error specifically. Whenever you call recover, it's whatever was passed into panic. And panic, if you look at it here, it takes in an interface, so it takes in anything. So recover also returns an interface, which is, pretty much anything. And that's why I can't call .error on this because I don't know for sure it is an error. I could do something like, a type check like this, and then I could call error on it if that was the case. But we're actually not passing in errors here. We're just passing in a string. So we're just going to go ahead and print out whatever that interface is to our response writer in this case. And then we'll just let that code be. Okay, so now that we have this working on the panic endpoint, let's just go ahead and go run main.go so that you can see it. Come back here. And I'm going to refresh. And you'll see here that we're now printing out oh no to the screen. So we got that string that we passed into panic, and we're putting it out here. So now that you've seen it working, I think it's important to stress that you should not use panic and recover like you would try catch or any of those other exception type handling patterns you'll see in other languages. It's tempting to do that because you effectively could do something very similar with this, but you shouldn't because it's just not the way Go is meant to be. You should be returning errors whenever you can actually recover from them. Panic is intended to be used for instances where you have an error that can't be recovered from. So that might mean that you just don't know the state of the system because of something happening that was out of your control. I think an example of this that I actually, I think I posted about it on Twitter. But anyway, an example of this is bytes.buffer. Let me go find this. And so there are functions like read from, and you'll see that read from will panic with error too large. So even though this function can return an error, there are times where it will panic. And usually what happens whenever this sort of thing is going down is that the program can't guarantee any sort of consistent state or anything like that. It doesn't really know, there's not a good way to recover from it because it just can't guarantee anything. So those are the cases where you'll generally see a panic because returning an error isn't that useful because you couldn't recover because they can't tell you the full, like this is exactly what's going on so you can do something about it. It's kind of like something went down or, it was too big, but we can't really promise that something didn't get messed up with memory. So, a program and like all that stuff is meant to have the panic happen and then it can sort of just exit from that point. So that brings us to the next question of, if panics are meant for unrecoverable errors, then why are we trying to recover from one? What's the point in recovering like this? Well, as we saw, there are times when you have a web application and you'll have a panic that'll occur for, one reason or another. Maybe you just can't recover and there's a panic. But that doesn't mean that we can't, at the very least, give the user a useful error message, or maybe we want to log something somewhere, or maybe we need to use a service like Sentry or one of those other log services that basically, let me get this up real quick so you can see. So this is like an error tracking type software. So maybe in cases like this, we want to notify somebody that this panic did occur so that we can, later on look into it and figure out what's going on. Specifically, in this panic case, what we're going to do now is we're just going to go ahead and code some sort of reasonable message to give to the user. But in the next exercise, you'll see that we're even going to take this a step farther, and we're going to say if we're in development, if we're not in a production environment, if we're just locally developing our application, we can actually create middleware that will allow us to really dig into what code is going wrong without leaving our browser. So it's going to be really cool. We're going to use the Chroma extension to do color highlighting on our code, and we're going to take the stuff that we write in this exercise, and we're basically going to make it so that whenever you see a panic, like this thing here, that it gets displayed in the browser, and that you can click on things like this, and it'll actually highlight the line that caused the issue, so you can just jump right into code from your browser. So that's where we're eventually getting with all of this. Okay, so I'm going to go ahead and go back to our code. We have this function that's recovering, and we've seen how to recover, but we want to create something a little bit more generic. We want something that'll take the entire application, so this entire mux that we have, we want to wrap that in some middleware that says, if there's a panic, this is how I want you to handle it. So we're going to go ahead and delete all this. And I'm going to delete this as well. And we're going to create a function. It's going to be called recover middleware. It's going to take in an http.handler, and it's going to return an http.handler_func. And I'm returning a handler func because that allows me to just return func, something that takes in a response writer and a request. And this is an implementation, or it's the same as this handler func. It's this, they're the same by definition, basically. And a handler func implements the handler interface, but if I were to return handler here, you'll see that this is now throwing an error because this isn't a handler. You can fix that by doing http.handler_func and converting this whole function into a handler func, but I find it's easier just to return the handler func, write my code like this, and then with this, I can use the handler func as a handler in other places if I want. Okay, so inside of here, we want to recover from any sort of errors. So what we're going to say is defer func, and I'm going to do this first. Before I do anything else, I'm just going to go ahead and create the deferred function, throw it on my call stack, so that it knows to run it whenever, if there's some sort of go or panicking. And then we'll go ahead and figure out how do we make the rest of our code work. So in here, we're going to say if error : recover, error is not equal to nil. So this is going to say if we call recover, it gets a value back and that value is not nil. We're going to assume that there was a panic at that point. So we're going to do http.error. We'll pass in w, something went wrong, and http status internal server error. So the internal server error is generally meant to be something like something in our server went wrong that we don't really know what went wrong. So, I think it's the 500 status code. Yeah, that's what it is. And we're going to use a generic error message because we never know what's going to be in this. Now, if you're doing local development, you can kind of do whatever you want. But for me, when I'm working on a production application or building something that I'm going to release to the world, I don't like taking random error messages that I don't know what's in them and displaying them to the end user. I just don't like doing that because, in a production environment at least. In dev, it's completely fine. But in production, I don't like doing it because you might give away information that you didn't intend to give away. Maybe it has some information about your database connection string, or maybe it has something else that's going on that you didn't want to give to end users. And you could end up accidentally printing this out and revealing it to your users who see this error page. So for me, if this error isn't specifically an error type that I wanted to render, I won't render it. I'll render something like something went wrong. And the easiest way to sort of do that now is just to always assume that we don't want to display this. We just want to, keep a generic message like this. But we're probably going to want to see what this is. So we can do log.println error and just print out the error in our log so that we can do something with it. And, I'm not going to get into logging right now, but, you should log it in some way so that you can, dig into it and figure out what was actually going wrong. Okay, so we've got the recover middleware. It's got its deferred function. But this middleware, as we'll see, or as we see here, does not actually, it doesn't use our app. So our app is never being called. We're not doing anything with it. So to fix that, what we're going to do is after this deferred function is added to, we've deferred it. What we're going to do is we're going to call app.serve HTTP, and we're going to pass in WNR. So this right here is just going to call whatever our application is. It's going to go ahead and call it exactly like normal. The only thing this recover middleware is doing is adding this deferred function call to the stack, and then it's going to go ahead and call it. So if this ends up panicking anything in this deferred function here will get executed and will recover from it. So now coming up here, we want to go ahead and do recover middleware, pass in the app. So this recover middleware is going to return that handler function we have, and we're going to pass that handler function into HTTP listen and serve. And this should, sorry, I got to figure out why it's erroring. I don't know what the problem is. It's probably something with the type. Oh, undefined app. Okay, that makes sense. So I'm not passing in app, I'm passing in mux, which we all know, or you probably know, implements the http.handler interface, so we can pass it in here. All right, so that should be everything. Now I can go ahead and stop my server, restart it, come back here, and you'll see that whenever we panic, it just shows the something went wrong error message. And then inside of our, our logs, we'll see the oh no message. So we're going to look in the next video at how to make this oh no message a little bit more useful, how to look at the stack trace and stuff like that. And then the other thing we're going to do in the video after that, I think, is I want to show you this panic after page. You'll see here that since we wrote something to the, the response writer, even though we recovered, that hello is still there. And what makes this even worse, if assuming this works correctly, is apparently I have an update, but I'm just going to ignore that. You'll see here that we've got a status code of 200 OK. That's obviously not what we wanted. If I go to panic here and go to network, you'll see that we're getting a 500 like we expected. So what's going on with this one is that once we start writing to the response writer, it's going to go ahead and set the status code to 204 if we haven't set one. So this is another instance where, writing to that response writer automatically triggers this side effect of the status code being set to 200. So we're going to look at how to handle that as well so that we can guarantee the status code is 500, even if our panic comes, halfway through writing the response. We have our panic recovery middleware. So the next thing we're going to look at is how do we look at a stack trace? So specifically, I want to explore, we've got, let me see if I have it. No, I don't have it. Let me go run this real quick and hit this page, and you'll see that we get this oh no message. We've got the HTTP multiple response writer calls. So we're seeing different error messages there. The second one's not, you don't need to worry about that right now. It's not super important for what we're doing. But the first one, and I keep pasting stuff, sorry. But anyway, the first one, the oh no message, isn't very useful because it doesn't really tell us where did this come from. What happened that caused this panic, and we don't have any context. So what we'd really like is something like a stack trace telling us, where did this panic really, derive from? Well, the easiest way to do this is to use either, let me look at the runtime package. There is something here called stack, I think. Index, yes, there's something called stack. And stack is going to format a stack trace of the call and go routine into a buffer and returns a number of bytes written. So basically it'll give you a stack trace. But realistically, you probably don't want to use this one. What you probably want to use is runtime/debug, which also has stack. But this one will automatically set the size of the byte slice and return you something that's already exactly as large as it needs to be. So it's kind of just a little helper built around the runtime stack. So what we're going to do is we're going to do that here. We're going to say stack is going to be debug.stack. And then we're going to say log.print print line string stack. So I'm converting this stack into a string to make it a little bit easier to read because obviously a byte slice isn't going to be what we want. And we're going to go ahead and print that out. So I'm going to save this. I'm going to go ahead and stop our program, restart it. And we're going to come back here and refresh. There should have been a panic. And you'll see here that now whenever we get the oh no, there's also a second message that has the full stack trace. Okay, so we've got the stack trace there. The next thing we're going to look at is related. We want to occasionally show the stack trace in the web request if, for instance, if we're in development. We want to be able to show this stack trace in the error message directly in the web request. It just kind of makes sense that when you're developing your application, you probably just want to see it rather than a simple, oh, something went wrong message. So what we're going to do here is we're going to come into our recovery middleware. We're going to add a second argument, which is going to be dev, which is a Boolean. And this is just going to be whether or not we're in development. So we're going to pass in true here for this recover middleware, we'll recall it. And then down here, we're going to go ahead and change our code a little bit. All of this is the same. The only part that's really going to change is this http.error. So we'll say if not dev, we'll do this. And actually, I'm just going to put this in, well, so we could put a return here. That's fine. It's kind of up to you as to how you want to style this. So you could do that, or you could do an if else. It's really whatever you think makes the most sense here. So what we're going to do if we are in dev is we're going to print something like format or fump.fprint. W is what we're printing to, and I'm going to do fprintf. W is what we're printing to. Then we need a message. So I'm going to do something like h1 panic with whatever the message was. Close that h1 tag. Then I'm going to add a pre-tag, and I'm going to put, we'll put %s, I think is fine. So we'll do, this is where we're going to put the stack trace. We're going to put that inside of this pre-HTML tag so that it's formatted correctly. And then we're going to pass in our variables here. So the first is the error. This error is coming from recover. It's whatever the panic was passed into it. And %s might not, maybe %v is better for that. So that should work for pretty much any value then. And then for the pre, we want to pass in a string version of the stack. Okay, so now we're going to stop the server, restart it, and everything that happens on the back end, you know, our log should stay the same. But you'll see now that whenever we run into a panic of some sort, and I'm going to go just to the /panic page, we get the message up top, but we also get a full stack trace here. And that means that, you know, when we're in development, it'll be a little bit easier to figure out that something's going wrong and figure out where it's going wrong, because as soon as we navigate to a page with an error, we're going to see this, you know, nice clear message that says, you know, something went wrong. So that's all we're going to do in this video. The next video, we'll jump into handling that panic after route that we've talked about a little bit. The next thing we want to look at is how do we handle that panic after, where if I start up a server, go run main.go, and we come to panic after. Basically, how do we address this issue where once we start writing to our interface, our response writer interface, you know, some of that content is already written and the status code is already set. So how do we make it so that doesn't happen? Well, the first thing we're actually going to do is we're going to do the HTTP Golang package, and we're going to look at what the response writer is. So if we come down through here, writer, I'm just going to click this, and then I'm going to click on the response writer type. So this is actually an interface. It's not a concrete type, and because of that, we can implement our own version of it. Now, there are some side effects of this, which we'll discuss in the next video, but for now, all you really need to know is that we need something that implements this header, this write, and this write header function. And as long as we have all three of these functions implemented, we can actually, you know, create our own header, or sorry, our own response writer. So what we're going to do here is we're going to create our own response writer, and we're going to use that to sort of buffer what's being written. So the main idea here is that we create a new response writer of our own, and then we would pass that in, we'll put NRW for new response writer. We would pass this into serve HTTP, and as long as everything goes well, this defer will never get called. So what we'll then do is copy everything, copy NRW to W. So we're going to take everything that was written to the new response writer that we made, and we're going to copy it over to the original response writer so that the message ends up getting sent back to the user. So that's roughly what we're looking to do. And the way we're going to go about doing this is basically, so let me take a step back too. On top of this, what we're going to do is, if we end up getting into our deferred function up here, this panic, well, the upside to this approach is that we don't have to do this last step, this copy the new response writer to the writer, to the original one. Instead, what we're going to do is we're just going to write our error message to the response writer, and whatever was in the new one, we're just going to go ahead and discard that, because we're going to assume that anything that was written to it was, not useful information because we panicked, and at this point we just need to show a generic error message. So to implement this interface, what I'm going to do is I'm going to come here and just copy all of this, and then I'm going to get rid of all the comments here in a second. So I'm going to copy it, I'm going to paste it here, I'm going to delete all of these comments. And you'll see why I'm doing this here in a second. I basically just want to make it a little bit easier to implement this. All right, so let me comment this whole thing out then. So we want to write something that implements this response writer interface. Well, the easiest way to do this is to just embed this inside of another type. So we'll do type response writer struct, and we're just going to embed an http.response writer. So by doing this, everything is exactly the same as it was. When we call header, it's going to call it on this original response writer. So we can come up here and update our code without actually having to implement anything first. So we're going to say nw : response writer, and we're going to pass in response writer is going to be w. And I'm actually going to make this a pointer, which you'll see why here in a bit. So we're going to pass in nw, and then the copying step we don't actually have to do because all of our methods are automatically going to be passed along to this. But long term we might need to do something there. So we have this. Now we need to figure out which of these methods do we not want to go immediately to the default response writer. Which ones do we want to have some control over? Well, if you go read the response writer, read the docs for it, I believe it's in here that it says, if write header has not yet been called, write calls. Basically, if you call write and you haven't set the header, it will automatically call write header with status OK. So it looks like write and write header are the two we really care about. And if you wanted, you could probably do something with the headers too. That's up to you. I'm going to skip that for this video because it's a little more involved and I don't really think it's worth doing right now for what we're doing. But it is something you could do. So what we're going to do here is we're going to say, all right, if they call write, we need to remember what they called so that later on we could pass it along. So I'm going to say that writes is going to be a 2D slice of bytes. And what I mean by that is write could be called maybe 3 or 4 times. So as a result, I'm going to take every single call to it and I'm going to add it to this writes slice. So that's why it ends up being a 2D slice. And then we have the write header provides a status code. So we need to keep track of the status, which is an integer. And that way we have that. It's also worth noting that write header, there are some pieces of functionality there that you might want to implement on your own. For instance, you can't call write header twice. You'll get some sort of error or warning message or something at the very least. So maybe when we write our own write header, that's something we'd want to keep in mind. Again, I'm going to skip that for this video, but something that as you build out your applications, it might make sense to keep in mind. Okay, so we're going to go ahead and write the response writer methods. And the first one's going to be write. It's going to take in bytes. It's going to call it B. And it's going to return an int and an error. And we're going to return the length of B and nil every single time. And we're going to say rw.writes equals append rw.writes B. So another side effect of this is that if writing to this, the original response writer would have resulted in an error, we're not going to actually catch that here. So this is going to be buffered and eventually we're going to flush it. So this is another downside to wrapping this type, is that you might lose out on some of those error messages you would have had originally, and they might not pop up until we get into this deferred function, or this whole recover middleware function. So it's something to keep in mind that maybe if this isn't too important to you, that's okay. For instance, I will sometimes release applications that, I don't really care if the user gets a 200 status code and they see something like hello, where is it? Right here at the top of the page. Because as long as I show them a generic error message that says, hey, something went wrong, they're going to realize that, the page had an error. These are pages meant for humans, so it's kind of okay. Where this becomes a little bit more problematic is when you're dealing with an API endpoint or something like that, where status codes are really important because machines might be looking at those things. So, then you need to decide, is it worth sacrificing some of this other stuff to make sure that I always get the right status code? Okay. So we have this part here, that's the write. We also need the write header. And this is going to be a write header, which takes in a status code, which is an integer, and I don't think this returns anything. No, it doesn't. All right, so what we're going to do here is rw.status equals status code. And I think that's it. So we have this implementing these two. Now the last thing we need to do is to take everything that was written to it and to flush it to the original writer. So you'll see here that if I stop this, rerun the program, and I go to just the home page, we don't get any response here. Well, what's happening is we're writing to this response writer, but we're not actually taking that data and flushing it back to the original writer. So we're going to go ahead and add an unexported function. And this one is going to be called flush. And it's just going to say, I think this could potentially return an error, so I'm going to put it there just in case we want to. So we're going to say rw.responsewriter.writeHeader, and we're going to pass in rw.status. And there is one exception to this. We need to say if rw.status is not equal to 0. So basically we want to say if we called this writeHeader function, 0 is not a valid value. So the 0 value is going to be 0. We don't have any checks here. So maybe we want to check here that says if rw.status is equal to 0. Maybe we do something like panic. I don't know. But for now, what I'm going to go ahead and do is just say if the status is not 0, we're going to go ahead and write the header rw.status to the response writer. Then we're going to do for each write in the range of rw.writes. And we're going to do rw.responsewriter.write. And this is going to pass in write. So this is going to return n, which I'm not really too worried about, and an error. And I'm going to say if the error is not equal to nil, we're going to return that error. Otherwise, we'll return nil at the very end. So this is, it's kind of a crude version of what a flush might be. We're not handling every potential error with our response writer type, but it's going to give you an idea of how you can take that interface we have. We can write a wrapper around it, and we can actually start to buffer some of that data and really get some use out of it. So what I'm going to do now is I'm going to come up here and I'm going to call nw.flush and save it so this code's formatted. And that should take everything inside of the new response writer and it should flush it to the original one. So let's go ahead and stop our server, restart it, and come here. And you'll see the hello page is working as expected. We can go to the /panic page. And again, this is working exactly as it was before. But if I put panic after, the one that we were seeing hello before, you'll see that we no longer have the hello message. And on top of that, if I refresh this page and look at the network status tab, we would like this to be status code not 200. We'd like it to be status code 500. So what we're going to do is come up here and we want w.writeHeader. http.status internal server error. And you'll see here that this actually wasn't a flaw with our current code that we just wrote. It was a flaw with the code we wrote in the last exercise where when we added this part, we didn't bother to add the header part of it, so we weren't getting back that error message correctly. Okay, let's stop, restart our server, come back here, and now you'll see that we're getting this 500. And it doesn't matter which endpoint we're at, we're always going to get this 500 because the response writer that's passed into this recover middleware that we're creating never gets written to until we call nw.flush, or up here when we just start writing directly to it inside of our deferred function that only happens whenever we recover. So that gives us the ability to sort of buffer what's going on here. Now, I mentioned the one downside is that you lose some of these errors. Whenever right here, we're never returning an error. We're just constantly just pretending like everything was okay. So that's one slight downside. Another downside is that we have to store all these writes here in memory, whereas, with the original response writer, maybe there was one that was implemented so that it streams the data to the client, and we don't keep it all on our server. So as writes happen, we can sort of free up some memory. So that's, depending on the interface you're using and how the whole system works, there are times where doing a wrapper like this, especially one that buffers things, could eat up a little bit of extra memory and, could, cause your application to be a little bit more memory hungry. The third downside, which is one we're going to look in the next video as to how to fix, is that our response writer that we just created, while it has this embedded one, it does not implement, I don't believe it's going to be detected as implementing the, where is it? So there are interfaces like Hijacker, and I'm going to go ahead and bring one up. And these are interfaces that you can see here, it's a standalone interface with just one function. Well, what happens in some of the server code, depending on the HTTP servers you're using and different stuff like that, there's also another one called Flush or Flusher, I think. Yeah, so there's one called Flusher, and it has this flush function that's on the interface. And you'll see here that it talks about how, Flusher interface is implemented by response writers that allow an HTTP handler to flush buffered data to the client. So you'll see here that the default HTTP 1 and 2 response writer implementations support Flusher, but your wrappers may not. So the way that you can handle this is you can do something, or the reason that's there is what I should say, is that in your code you might have something like NW, basically you might have something like if temp, I'm just going to put an underscore because I don't care. Okay is going to be nw.http.flusher. Okay. So what you're saying here is if nw implements this http.flusher, you want to go ahead and this could be your, I'll put f here so we have it. F is now of the type flusher. So we can actually call this flush. Well, the upside to this is that this would actually have been done with w, not nw. So if W was to, this original response writer was to implement the Flusher interface, we would no longer have that implementation with our new response writer because it's a wrapper around it, and it's not going to check if W, it's going to instead check if NW implements this interface, and you can see here that we do not implement it. We have this flush method, but it's a different method than the flush that they're talking about. So basically that's the third downside I wanted to discuss was that there are interfaces that the response writer also might implement that aren't obvious because they're not being passed into your handler functions, but sometimes you can have extra code that does something based on whether that's there. So for instance, your server might decide to flush data occasionally when it knows that it's implementing the http.flusher interface, but in this case, all that functionality would be lost because our wrapper no longer has that. So in the next video, we're going to look at how to go about doing that, just a quick way to do that. And, from there, you'll have an idea of how to do it when it's something that's important to you. But I found that for most simple applications, it's not a huge deal. So it's really specific to whether or not you need it for your specific applications. And, you kind of make that decision on your own. In this last video, we're going to look at how to implement different interfaces that our response writer might not implement. But I'm going to warn you that there are a couple cases that are really hard to handle well. So it's something to sort of keep in mind. And you might have to know a little bit more about your application to know whether or not it's an acceptable thing to be doing or not. So I'm going to start with the hijacker interface, which I think is easier. And then we're going to jump into the trickier one, which is the flusher. Okay, so let's go to the hijacker type. And you'll see here that the only thing this needs to implement is this hijack method. So what we're going to do is in our code, we're going to add something like func rw response writer, and we'll add this hijack, and that's, it's all there. So now we need to add some return values to it, and we need to basically make sure that we allow our code to, handle this correctly. Well, I'm not actually going to worry about, there's a chance that, maybe hijack would break some of our code up here. I'm not going to worry too much about that right now. That's something you could think about on your own later. But, for now, I'm just going to go ahead and show you how to implement this interface, with our response writer type so that whenever you build your own wrappers like this, you can actually go about doing it. So what I would probably do is say something like hijacker, okay, our rw.responsewriter.http.hijacker. And this right here is a type assertion again. I actually brought up the doc so you can see it. I will try to remember to include this link, but essentially a type assertion just allows us to, verify that this does indeed implement the hijacker interface, and if it doesn't, okay will be set to false. So then from here we can say if not okay. This is when we do not implement the hijacker interface. So when this happens, we need to handle that situation. What we're going to do is we're going to return nil, nil, and then something like fumpt.errorf. The response writer does not support the hijacker interface. And I'm going to go ahead and just mention that this is not the ideal scenario, because if somebody is writing code on their server, they would have done a check like this and they would have thought that, oh, it does implement the hijack interface because our response writer does. So this is, again, it's not a perfect solution, because they could still get an error message back instead of just being told, oh, it doesn't implement that interface. So that's like one of the shortcomings of the interfaces as they are in Go right now, is that whenever you wrap an interface, it's a little bit tricky to keep those extra interfaces that might be implemented, and to keep consistently determine whether or not they're implemented correctly. That was probably not phrased well, but hopefully you understand what I mean. Okay, so assuming that we do implement the hijacker interface, we would be, at this point in the code, we would have not returned from this if statement. So at this point, we're going to return hijacker.hijack. And, this is coming from the response writer after it was, done a type assertion, and we get the hijacker type. So we can just return whatever that would give us. So you see here that in cases where there is an error being returned from the interface method, we can get away with just sort of putting an error message here, and it's not perfect, but it works at least well enough to make our application work. Where this falls a little bit short are interfaces like the flusher interface, which I'm going to go back to now. Well, if I can get my browser to get there. So the flusher interface has this flush method, and you'll see that it doesn't return anything. So we don't really have a spot to return an error. So if we do something like rw response writer, and we add flush, you'll see here that we could do something like flusher okay is going to be rw.response writer. We'll add this type assertion. And we can say if okay, flusher.flush, return. But what happens if it's not okay? What do we do at this point? So there's basically two things we can do. One is to silently just do nothing. So we could say if not okay, return. And we could essentially just be hoping that this flush doesn't matter too much. If we don't implement, and in this case, I think it's actually fine, because if a client doesn't support flush, I think this is basically just the same way it would have acted anyway. We wouldn't have been able to flush anyway, so we would have never called it. So this isn't terrible, but if the end user was expecting something to happen from this, like say they were really expecting data to be written and it's not, and they can't figure out why, this is another instance of where it can cause some confusion because, it's not really obvious. Another thing you could do here is add something like a panic, but again, not ideal because, now we're breaking code that the only reason it's breaking is because it thought we implemented this flusher interface that, one of our response writers might not implement. So none of these are perfect. So you just need to use your judgment, decide what you think is best for your application. But for now, I'm just going to leave these two here, and I'm going to leave this one do nothing, this one will return the error, and hopefully they'll be good enough for what we're doing. Even though I'm not going to be using them in this application, I want to leave them here so you can see what they're like. Oh, and lastly, before I leave, because this is the last video, I want to show you some examples of this in the wild so you can see what it's like in different applications. And the first place I think I ever saw this was in the Negroni middleware, which is, let me go ahead and just grab the base URL. It is github.com/urfave/Negroni. And maybe this isn't the first place, but I think it is. If you look in here, if you look in like responsewriter.go, is this the right one? It's responsewriter.go, line 96, you'll see things like the flush method that we just talked about. And you'll see here how this is being dealt with, what they're doing. And you'll see this has a little bit more logic to it. So it's calling things like writing the header. It's trying to do a little bit more. But this whole type, if you look through it, is doing something very, very similar to what we have. If you go to Negroni in the, just their homepage or their README, you'll see they have a recover. Right here it is, Negroni.recovery, which is their panic recovery middleware. And this essentially does the same thing we were talking about. It will capture any sort of panic errors, recover from them, and then render it in a nice little something went wrong page. So that's really what's going on here, is they just created their own panic recovery middleware to sort of let people reuse it. And that's what we were implementing in this entire exercise. But I wanted you to see how you'd go about building it yourself and some of the stuff they're doing. But if you want to go check out their source code to see, how did they do it, it's a good place to start. Another place to look is pretty much any HTTP framework or router or any of those things that provide some minimal, middleware. So I think Chi is another one. Let me go see. And let me go to the middleware section. I don't actually want to go straight to that. Wow. All right, I'm trying to see if they talk about middleware anywhere. Okay, you'll see here they have middleware.recoverer. I'm guessing if you go look in the docs for that, it's going to be, or the source code for that, it's going to be very, very similar to what we just did, what we just created and what we discussed. And I'm going to go ahead and just look real quick. Well, they at least do the deferred function with the recover. They don't appear to be doing anything with the response writer. They don't wrap it in any sort of way. But you'll see that they, at the very least, they create this function, and they return as a handler function. So, it's very, very similar to what we just did. They're doing this deferred function, recovering, getting a log entry is something else they're doing. I'm not really sure what specifically that is. But, then they go ahead and do through the rest of this. So again, a lot of applications are doing something similar. So if you want to see some examples of it in the wild, I definitely recommend checking out different packages, different routers and middleware packages, and see how they're handling it to learn from them.